Why does a dropped ball fall downward? The short answer to that question is that it's pulled downward by its weight, and it accelerates downward in response to that force. In other words, when you let go of the ball, its weight dominates its motion and it plummets. Well, weight is associated with gravity, and gravity is a physical phenomena that produces attractive forces between every pair of objects in the universe. This ball is exerting an attractive force on me by way of gravity. I'm exerting an attractive force on the ball by way of gravity. Every possible pair. But gravity is a very weak phenomena, and as a result, the only object big enough to produce noticeable gravitational effects, that is, ones we are routinely aware of, is our Earth. The Earth exerts a downward gravitational force on every object in its vicinity. It pulls this ball downward with a gravitational force. It pulls me downward with a gravitational force. It pulls you downward with a gravitational force. And we give a name to these individual gravitational forces. This ball's gravitational force due to the Earth is known as its weight. And this ball is experiencing its weight due to the Earth. I'm experiencing my weight due to the Earth, and you're experiencing your weight due to the Earth. To observe the ball's weight in action, let go of the ball and let it accelerate. The force that's causing that acceleration is the ball's weight. It's a force exerted on the ball by the Earth's gravity, and the ball itself responds to that weight by accelerating, by falling. Since the ball's weight is the force that the Earth's gravity exerts on the ball, the only way to observe it directly is to let go of the ball and watch it accelerate. The weight pulls down on the ball, and according to Newton's second law, the ball accelerates downward in response. Well, what determines the ball's weight? It turns out that the ball's weight is exactly proportional to the ball's mass, and that's a remarkable result. Remember that a ball's weight is a force exerted by gravity, whereas the ball's mass is its resistance to accelerations. How hard is it to make it change velocities? There's no fundamental reason why weight and mass should have any connection to one another, and yet they do. It turns out that, just from observation, that every kilogram of mass here near the Earth's surface weighs about 9.8 newtons. So the weight of an object is 9.8 newtons per kilogram of its mass. Now, remember that a newton, 1 newton, is the SI unit of force, and it's about the force that a small apple, conveniently enough, given that it's Newton, a small apple exerts on your hand when you hold the apple there steady. There are about 4.5 newtons in 1 pound force, for people who are more familiar with pounds. So this ball, it's probably about 10 newtons, maybe something like that. All right, the fact that there's that relationship between the object's mass and its weight is convenient, but what to call that 9.8 newtons per kilogram, what's known as a constant of proportionality, what do you call it? Well, it's conventionally represented by the letter G, the lowercase letter G, and it carries a mysterious name. It's called the acceleration due to gravity. And in the next video, we'll take a look at why that name is appropriate.